This is a video about how to do your IMU calibration for real. Before we get started, I'm just going to do a short demonstration as to what motor control by remote control actually looks like. Our motor configuration, and we're going to drop the current scale to 5% min, 5% max. And then the next thing we're going to do is we're going to go into our app configuration, set it on the balance app, jump down into the balance tune, set this at a PF5 value, grab the machine. So as you can see, it's not doing anything. Our real-time data screen, we can see that the orientation looks totally incorrect. So we're going to go start changing some values on our app config and try and get the IMU just in the general correct position. Now it's important that you only rotate by orders of 90 degrees. Still not correct. Closer, but it looks like it's upside down. Oh hey, it's doing what it's supposed to be doing. In this case, we didn't have to rotate the yaw. We only had to rotate the roll and the pitch, and I recommend keeping it to around 90 degrees or 180 degrees, positive or negative as necessary. So now that we have determined that the balance is actually doing what it's supposed to be doing, we're going to move on to the real purpose of this video. How do you go about IMU tuning? So the first thing that we're going to do, now that everything's working correctly and the system's giving us a response, is that we actually have to stop it from doing that. Go back to the General tab, switch to No App. Right. Now your balance system will shut off and we can set it up for the IMU calibration stage. First thing we're going to do is actually get the physical orientation of our device, of our VESC, everything, all in a correct and level position. I've been doing this for a while, so I can just do it by eye, but if you have a digital level, regular level, level app on your phone, any of those are just fine. That looks good to me. So, the next stage is that we are going to go back to the main balance loop and set everything to zeros. Specifically on the PID main loop. PID at 0, right? This allows us to turn on the balance app to get the real-time data without it doing anything. So now the balance app is actually running and it's not going to go forward or backwards or whatever. And this gives us a nice stable position to tune from. The next thing we're going to do is enable the TPC bridge, TCP bridge. You enter your IP address and connect to your PC. It has to be on the same network. It's fairly simple. On the start page in your mobile app, just scroll down to wireless bridge to computer. Hit activate bridge. Then you go over onto your computer side, jump into the connection tab, and you're going to see over here under TCP, you can plug in the IP address port and hit connect. Connect. So you can see it popping up down here on the bottom. So to do this most easily, you want to use the IMU calibration page on your mobile app and use the IMU real-time data on your PC. This will keep you from having to flip between multiple windows in order to get this done quickly and effectively. Be sure not to click on the real-time analysis IMU data because that won't help you as the app settings IMU data will. Enable the real-time data, real-time app, and IMU on the right-hand side of your VESC tool. And this is where it gets different from others. So make sure that aside from your rotation offsets in the IMU under app config, that The other offsets, accel offsets and gyro offsets, should all be at 0. In your real-time data screen, you're going to see several lines moving. Focus on the z-axis. That's usually the one that's closest to the 1 value on the g scale here. You'll notice it is riding quite a bit above, and this accelerometer is kind of so-so in this orientation, so we're going to have to do some significant corrections. How we do that is we go into the related accel offset axis in the app, and we start adding some numbers. Pretty straightforward, basically like what other people have done. So I'm just going to keep adding a little bit to the z-axis accel offset, and here we are, a little below. All right, that looks about perfect. So in order to check how perfect it is, I'm going to pause the IMU data and zoom in. It looks basically dead on, just slightly, ever so slightly above the 1 line. And I prefer that the data never strays above the 1, so I'm going to push it down just a little bit. Enable the IMU data, let it flow for a second. I consider this to be close enough. Now we're going to move to the other axes. This is the main fundamental difference of this method from any others. You don't move the device to tune these axes, you just do the math. Subtract 1. So all of these should be hovering around 0. What we're going to do is enable real-time IMU data and start moving the other 2 accel offsets just by any arbitrary number and see which way it pushes the line. Looks like it went the wrong way. Right. This is pretty close. Looks about right. Now we're going to do the y-axis. Looks like it doesn't need very much. Now to double check the accuracy of our tune, we're going to let it move for a minute and then zoom in. Looks like it's pretty good. Overall, not peaking above 1. That looks not peaking above 0. That looks ideal. And it's set. You have a tuned accelerometer. The next thing we're going to do is the gyro calibration. And to be honest, this is not the clean graph you're used to on the Excel page. So we're basically going to have to do some estimation. And how we do that is based on the amount of color above or below the 0. So we're going to re-enable our IMU data. It looks like the most significantly incorrect one is the Y. And in most situations, you'll notice that there is only one majorly incorrect axis. The other 2 are typically pretty close to where they're supposed to be. So we're going to scroll down to the gyro offset Y. We're just going to start adding some degrees per second. It's like way off. It looks like it's just about 1.6 degrees per second off based on that graph. So we're just going to scroll up to 1.6. That's pretty close. I would say that in this graph it looks like the green is just slightly below the 0 line where it's supposed to be. The green represents to gyro X, so we're going to start adding a little bit to that. Wrong direction. Looks pretty good. In this case, gyro X, the blue line, is totally fine. And the Y and the X are the only ones that needed significant correction. Now your output result should be very smooth. Your yaw chain should be very slow. We can go over to the real-time data and see what's going on. But ultimately, the accel X, the accel Y, the accel Z should all be very, very close to where they are. The gyro X, gyro Y, gyro Z, as shown in the app data, those should be flipping back and forth between a negative and positive number at an equal rate. That will mean that the average is 0. Now, we're going to turn it back on and see if we did it right. So, going into our app configuration, we're going to hit General. It's already on the Balance app. We're going to go down to the Balance app. We're going to enter the parameters we already figured out before. Now, if everything goes right, it's not going to fly around the room on me. Hey, what do you know? It does what it's supposed to. And now I have a dead-on tuned accelerometer and gyroscope. One significant factor is that when it rotates, it's dead level. There's no pointing up or pointing down of the pedals. Dead on, totally, every time.